Just to set the stage here, the Rimac river system is one of the largest rivers that actually flows through the city of Lima, where there are at least 8 million residents. It's one of 3 very important watersheds that supply drinking water and multiple other uses to the city. And the Rimac itself is the largest supply of the 3 rivers. The city also, it's important to note, gets now I believe a majority of their water from the Amazon basin. So the city is actually pumping water over and through the Andes Mountains to get a large proportion of their water supply for the city. But focusing more specifically on the Rimac, this is a very important water supply for the city itself. The challenge has been is that there's been very limited water or watershed management around this river system and the 2 rivers to the north and south. The Rimac, the city of Lima, it's difficult to see on the map. I don't believe we have a pointer here. Lima is on the coast of the Pacific Ocean, and the green colored area is one of the 3 watersheds. That's the Rimac. The Rimac has a history of water quality problems. There's limited regulation on industrial discharges, mining discharges. There's also, thank you very much. So here is the city of Lima. This is the Rimac watershed. Lots of pollution problems, to say the least. The city is also a very arid portion of the country. The city rarely receives any rainfall. The rainfall supply is typically from the Andes, and that is very seasonal. So during one portion of the rainy season, the river, which is a very large river, will run full. The remainder of the year, you'll have very limited water supply. That water is tapped for hydropower uses. It's tapped for agricultural irrigation and the drinking water supply itself. Well, one of the challenges that many of these water funds face is how do we best invest in our projects? And the water fund specifically here in Lima was set up to address these water quality issues and water quantity issues in the basin. It is not the only solution available, but it is one of the solutions that's being examined. And so the real challenge with the funds has been is how do we spend our dollars effectively? And so what often happens in these programs as they begin to start up is you have a lot of funding. As you begin to invest in projects, you have dwindling benefits. You may have, as you kind of go down this triangle here, you may have great community benefits, but as you get to the environmental outcomes, the desired outcomes of quality and quantity, oftentimes you can end up with very low value projects. So the real challenge is how do you reverse this? How do we avoid this situation? And then how do we get to a scenario where we have very wise investments that increase community benefit and in the end have a much greater environmental benefit so that we end up with very high value projects. And one of the ways that we've been working with the fund, the water fund, has been to emphasize this idea of the environmental outcomes and quantifying those with each type of project, and then using that, equating the environmental outcomes back to your investment, the amount of money that you're willing to put into these projects. And there are parallel situations where there are water funds in Latin America that have spent a lot of money, but in retrospect, it's difficult for them to go back and say, these are the actual quantified benefits that we have in terms of improved water quality or increased water quantity. And a lot of what we've been suggesting here, here for Aquafundo comes from the regulated water-based programs that we have in the North America, especially in the United States, where we're very interested in the performance-based outcomes of our projects rather than just the projects alone. So one of the things, or some of the objectives that we had in this particular project was, in this vein is we wanted to look at a number of the quality and quantity concerns that might have similar solutions. Does reforestation have a value for water quality as well as water quantity? And then looking at those common solutions is identify a performance metric, some kind of a common environmental metric that no matter what the project is you always gauge the value of the project based on water quantity or water quality specific to the particular concern. Using that idea is you develop a framework around that for funding. And again, this is not the only program in the watershed, but this particular program is looking to fund projects. And so that's really our specific goal, is to how do we do that cost effectively. In this project, and this is part of the Forest Trends program, international program here, where there are incubators across the globe looking at these issues, as well as here in the Peru watershed. We'll pilot test some of these applications. And to really illustrate what we're trying to do here, and this has been helpful as we talked to the various different ministries in Peru. We heard our colleague Lucia talk about the different silos, the different ministries that each have their own objective. Is as we look at these particular projects in the context of a performance metric, we start speaking the same language. So for example, if we're dealing with, we're looking at infiltration projects, where we want to increase the amount of surface water that is infiltrated back into the groundwater that provides kind of that year-round sustained supply, we may have multiple solutions to do that. Multiple different types of projects, that be it reforestation, irrigation improvements, rainwater capture, even wetlands. And the key here is each one of these projects, if we look at these in terms of how does it perform, is we establish a metric that we can use across projects. In this case, we look at flow. This is cubic meters per second. So if every project is evaluated in terms of this common metric, we have to calculate it. There are some established methods. In many cases, many situations, many countries, it's often difficult to actually find these types of methodologies that you can apply to a very site-specific project. Sometimes it's a very coarse estimation. Other times we have a very finite type of analysis that we can use. But fundamentally is for each particular project, we come up with a consistent set of information for each project to be able to compare these across the board. And the same can apply for conservation projects, where we're looking to conserve water, either through water reuse, maybe urban water conservation. We use that same metric, cubic meters per second, so that for each particular project that may be proposed, the fund says, tell us what the flow is, tell us what the volume of water is in cubic meters per second for your project. And as you have several projects to consider, limited funding, you can then choose those projects that are most cost effective. The same can be said for our Chinese colleagues. This will be in the PowerPoint, but we'll leave this up for a second. The idea here is rather than having a decision making that must rely on a variety of different factors, be it socio-political factors, be it a type of project, the idea here is basically to have that one common performance metric that makes it easy to consider your different costs and different investments. So the same can be said for water quality projects. You may have a variety of pollutants, in this case sediments, a variety of different types of projects, stream bank restoration, stream buffers, animal exclusion, again wetlands. But what's the common metric? In this case, it's how does that particular project reduce metric tons of sediment per year? How much will that project get us for what cost? Again, it's you have different calculation methods. Fundamentally, each project, no matter whether it's nutrients, heavy metals, organic enrichment, every one is evaluated on the same type of metric. For other pollutants, it might be kilograms reduced per year. What we could do then is for each project is, if a project is $1,000, you could look at the environmental benefit that comes from that, and you could calculate the cost per metric ton of sediment, for example. Well, ultimately this gets tied into some kind of a funding framework. This is my last slide here. As the investors put money into the fund has to make some decisions, and there'll be influence. Some of those decisions will be influenced by agencies and other organizations that have interest in the watershed. Fundamentally, they're going to have to solicit projects. Through that project solicitation process, again, you'll have other input, but here's the critical piece where we have to quantify these values. As the fund looks at the different proposals and the different investment opportunities, we use these metrics and these calculation tools to help us understand what the value of those projects are. We can then rank those projects. You can then fund those projects. And through the implementation, there may be third parties that get involved in the process to make sure that the projects are going in as proposed, to ensure that the environmental outcome is being established. And then certainly there's some oversight. And I think fundamentally what's important for investors is to have feedback in terms of what have we gained or what have we paid for, and then to the public, as part of that public transparency process, is being able to report out. So this, in essence, is the framework that Aquafundo is considering for their fund as they move forward. The fund is looking at, I think we have there marked, I think there are a couple of pilot projects that are now underway. And the notion is that we'll use this framework in this process to help the fund evaluate what projects that could be chosen, and then clearly track the value of those projects. Deputy Director, thank you very much.